Hey everyone, and welcome to our final video of this series. We're going to take the things we've learned about equations as well as the inequalities we introduced in the previous video to look at solving some basic inequalities. Now, I'm not going to go too deep into this. I just want to, because this is an extension topic, you deal with it a lot more in later years. I'll talk about it. I want to save the bulk of the stuff for those videos. But I just want to introduce you to this, just give you a couple of examples for you to have a go at and along with me, and just to show you how we can draw upon all of the different bits of information that we've learned so far. So what we've learned about inequalities and what we've learned about solving equations systematically. So to solve an inequality, first I want to just tell you what that actually means. So because you're going to notice when we solve this, it's going to be quite different to solving an equation, at least the answer that we get. So I'm just going to write a little thing down here. To solve an inequality, means we want to find all the values that make it true. That make it true. Now, I've said a handful there. So I want to just jump straight into solving something. And we're going to come back to this idea because it's quite important. And a bit that I want to draw your attention to is this idea of finding all the values that make it true. This is quite an important idea because when we get to a solution, you're going to see something really important. Now, there's a hint here in this bit that has values. It's a plural. So this tells us a bit of a hint as to what we may expect from our solutions. But enough of that. Let's jump straight into a question. Now, it's important to know that inequalities, although they're different to equations, they communicate different information to us, we can solve them in the same way that we would equations. So I have a number x that when 2 is multiplied to it and 4 is added, it's going to be less than 10. So in the same way for solving equations systematically, we can just look at the last thing that was done to the x, and work our way backwards to isolate our value of x here. So I notice that 2x, when 4 is added to it, I get something less than 10. So that means that before the 4 was added, when we take this reverse step, then that means that 2x was less than 6. This is the same idea we've been working on with equations. We're just, once again, solving systematically. And now here, I get that a number 2 when multiplied by x is going to be smaller than 6. Now, what I want to do is I want to consider once again the opposite operation, because this is like saying 2 times x. I want to divide both sides by 2 to isolate my x. That's going to kill these off, and it's going to leave me with a value for x. So x is less than 6 divided by 2 gives me 3. Now, what does this actually mean? Well, this particular thing here means, to refresh your memory, it's a bad arrow, let's do that again. This means less than. So this doesn't mean that x equals 3. That means that any value less than 3 for x is going to satisfy my initial inequality. So that means if I substitute anything less than 3 for x into my x in the question, so there, I'm going to get something that satisfies this, which is going to make my left-hand side less than 10. So let's pick a couple of values, shall we? So, and just to test this. So what we're going to do is we're going to try letting x be 2 and substituting that in. 2 is a number less than 3. So it should work when we substitute it into the equation. So my equation here is 2 times x plus 4. So I'm going to substitute that in, and I get 2 times 2. So instead of x, I've just put my 2 from here. That plus 4 should be less than 10. Now, 2 times 2 gives me 4, plus 4 gives me 8. 8 less than 10. So is this satisfied? Well, yes, it is, because this is a mathematical truth. 8 is, in fact, a number that is less than 10. So our inequality is correct. Substituting a number less than 3 gives me a value, once it's subbed in on the left-hand side, that is in fact less than 10. Now, just to check this, let's try a number greater than 3 and see if I still get the same thing. But we'd expect it to not be true because it's not within my constraints. If I were to draw the number line from 1, 2, 3, 4, I'm looking for x is less than 3. I want a number somewhere on this side of my number line. So I would expect that this 4 is not going to work. But let's just double check it just to see. So what I'm going to do, I'm going to say try letting x be 4. And I'm going to check if my inequality still stands. So 2 times, in place of the x, I'm going to put 4 plus 4 is less than 10. So 2 times 4 gives me 8, plus 4 gives me 12. Now, is 12 less than 10? No, it's not. 2 is actually bigger than 10. So what we have here is nonsense. That's wrong. 12 is not less than 10. And that is why my value of 4 didn't actually work, because it doesn't obey the solution I came up with. And the solution I get is any set of values of x as long as they're less than 3. That brings us back up to here. Find all the values, plural. We have more than one value of x that will make this statement true. I showed one of them here. But you guys can try at home. Try substituting 1, try substituting 0.5, try substituting minus 10. All of them will give you an inequality that works, that is true, like this one here. Anything that doesn't satisfy my inequality that I got for my answer, anything that doesn't satisfy this, will give me something like this that was utter nonsense. It didn't work. Now, we'll try one more example. And here, I'm going to add one more extra step. But by now, you should all be, if you've gone through my previous series on solving equations, as well as the previous video on inequalities, this should, although it looks a little scarier, this should be relatively approachable still. So I have 3 plus 4x over 9 is greater than or equal to 3. I want to solve this inequality. And I can do it in the same way as I did when I solved my equations, looking from in terms of the systematic approach. I'm looking at my x, and I can see first I multiplied 4, then I added 3 to that, then I divided by 9. The dividing by 9 was the last thing I did. So I can find what this numerator is by what it was before dividing by 9 by doing the opposite operation, by timesing by 9. So I'm going to times both sides by 9. And I get 3 plus 4x is greater than or equal to 27. And that makes sense, right? Because when you divide 27 by 9, you get 3. When you divide 27 by 9, you get 3. My systematic approach works. So let's look again from the perspective of x. The next last thing that was done to it was adding 3. So I can find what 4x was before I added the 3 by doing the opposite operation, by minusing 3 from both sides. And that is going to give me that, well, that gets rid of this here, and that leaves me with 4x. And that is, greater than or equal to 27, 3 less than 27, and that's going to be 24. Okay, I'm on the right track. And the very last thing is just to consider what operation's being done here. This is 4 times x. We just write it in a shortcut way when we talk about algebra. So I'm going to divide by 4 and divide by 4. And finally, I get that x is greater than or equal to 6. So this now means that if we draw this on a number line, so I don't know, we'll go 5, 6, 7, 8, 9, 10. That's pretty ugly. Let's try that again. I'm looking at every number that is greater than 6 as well as 6 as well. It's greater than or equal to 6. That's what this symbol tells me. So if I wanted to draw this on my number line, well, I would say that the 6 is included. So I'm going to do a closed circle. So it's 6 as well as everything bigger than 6. So every single number to the right of 6 on the number line will satisfy this inequality. Now let's just check one just to make sure. Let's try the number 8. And you guys can try another number at home if you want to practice. But let's try. So let's try letting x be 8. 8 is a number that's greater than or equal to 6. So this should work. And when we substitute this in, we get 3 plus 4 times 8 divided by 9. Greater than or equal to 3. So 4 times 8 gives me 32. So 3 plus 32 divided by 9 greater than or equal to 3. Now I'm going to add my numerators, and that gives me 35 over 9 greater than or equal to 3. Now I'm not going to get the nicest answer here, so I'm just going to round it. This gives me roughly, 3.888 repeater. Now, is this greater than 3? Well, it's a decimal, but it is still bigger than 3. 3.888 is still bigger than 3. And this is how we can apply our inequality to check. So once we find what x should be, something bigger than 6, checking a bunch of numbers that satisfy this, because we're not looking at just one value, we're looking at multiple values. Going back up to that first sentence, we are finding all the values that make the inequality true. All the values that make this particular second inequality true is the ones that are greater than or equal to 6. All of these will work if you sub them in. All the ones that don't satisfy the inequality, say 5, will not work. And you can try and show that at home just for practice if you'd like. But that brings us to the end of inequalities as well as the end of Year 8 equations. I've only dealt with here the topics that are new. All the other ones, the solving systematically, the fractions, the brackets, the applications, worded problems, formulas and rules, we've already done that. So I just want to introduce you guys to the new stuff that comes up. But that brings us to the end of the topic. Thank you so much for watching, and I'll see you in the next series.